Hello students, welcome to the next lecture on the complex linear transformation. Today I will explain you the important property of this transformation is magnification. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can find the playlist of the complex analysis. In this playlist you can see I had uploaded the concept of the complex linear transformation, conformal mapping, Schwarz lemma and many more lectures. All are available with the help of the various examples in the easiest manner. You can follow and subscribe my YouTube channel. What we have discussed so far, we have covered the concept of the complex linear transformations where we have defined the variable z is x plus iota y and called as the z plane. On the other hand, by using some transformation, we can define the new variable w which is called as u plus iota y, and this plane is called as W plane, and our target is to find the image of this pink color to the W plane. Whether if it is a circle, then will it be again a circle, or the circle will change into the triangle, straight line and many more else. And the capital T is the functions from the complex plane to the complex plane is said to be transformation. Do you remember that when it's said to be the transformations? This said to be the transformations if you prove that the t is my 1 1 and the t is my on 2. And if you prove that is basically if you prove that the t is my bijective map, then you can say that mapping is my transformation. Now we have seen there are the various special categories like translations, rotations, dilations and so on. In this we have discussed so far these two lectures in our up to the last lectures. We have covered the concept of the dilation in this lecture. The dilation is also known as the magnification. As the name suggested, magnify. Fine. What is the meaning of the magnify? That means if you have the graph like of this small triangle, then what will happen after the magnification? The graph will be look like this number. Fine. And that is the objective of this today's lecture. Any of the mapping or any of the map T which are mapping from the C to C, which are defined like K into Z. Fine. Where K is my positive, K is my real number. Fine. If K is my real number, then you can say this transformation is said to be the magnification or called as the dilation. Clearly say whenever K is my greater than 1, then and what will happen if K is my less than 1? If K is less than 1, then it will shrink the image, and if K is my greater than 1, it will be stretching the image. For example, if my original image is triangle, fine, and if I choose say K is equal to 3, that means the graph will be magnifying by 3 times. Is it okay? On the other hand, if I choose K is equal to half, then what will happen? The graph will be shrink by half. That is the meaning of the K. This transformation is also known as the homothetic. Fine. And as I mentioned you, it will be either stretch or shrink depending upon the value of the K. That means whether the K is my positive or K is my greater than 1 or K is my less than 1. Whenever K is greater than 1, we can stretch the points, and whenever K lies between 0 and 1, it will be shrinking the points. In both the cases, whether it's a shrink or whether it's a stretch, we called as the concept is dilation. Geometrically, if you have the original image in the Z plane defined as a Z, then what will happen if you consider the mapping T of Z is KZ? So if I assume the K is my greater than 1, what will happen? This image is my stretch, and you can see the graph of this image W is basically my T of Z is my stretch. Another important property is the shape of the graph. Whatever the shape of the graph does not changes while using the transformation. What will happen? The shape means if the original image is my triangle, then after the transformation it is still the triangle. On the other hand, if the original image is my circle, then after a transformation it is still my circle. The shape of the circle is remain the same, but it's a radius, diameter, it may change, but the shape will not be changed. That is quite simple. Why? Because if you consider that z is my r e raised to power iota theta, then what is the value of the t of z? This is k r e raised to power iota theta. So can you find the magnitude of t of z? That magnitude will be my k of z, sorry, k of r. Fine. And what is the r? I can say the r is nothing but my magnitude of the z. So therefore, you can find the relation between the transformation and the original vector or original element z. It's multiplied by the k. So that means it is multiplied by the factor k. Now let's start with the various examples. The first target is you have to prove that the mapping which we have defined is a linear transformation. That means your target is to prove the mapping is my 1 1, mapping is my onto. The proof is a very simple. How you can prove that the mapping is onto? Fine. And how you can prove that the mapping is my 1 1? So for the onto, we can always take the elements from the codomain. Fine. So let W belongs to the C such that W is equal to T of Z. Then your target is to find the value of the Z and check whether it belongs to the domain or not. Fine. Let's start with this. What is the value of the T of Z? T of Z is my K of Z. So this implies the value of the Z is W over K. Now W is my complex number, K is my real number. So what does it implies? W over K belongs to the complex number. Yes, we can find the value of the Z. Therefore, T is my onto. How you can prove the 1 1? I can take the two elements from the domain. Let Z1 and Z2 belongs to the domain such that their images are equal. Then what is your target? For the 1 1, your target is to prove the elements are also equal. You can substitute the value of the T of Z is a K of Z1, which is K of Z2. Hence, Z1 is equal to Z2. This implies T is my 1 1. Once the T is my onto and T is 1 1, therefore the mapping, the magnification or the dilation mapping is basically a transformation. Okay, look at this another one. Consider the transformation T of Z is equal to 3Z. Fine. So that is, again you can see this is the magnification. Find the region in the W plane into which the triangular region of the XY plane. This is my XY plane. Fine. That is called as Z plane. So can you draw the region? Clearly say X is equal to 0. This is the line of X0. Y is equal to 0. And X plus Y is equal to 1. This is the graph of the Z plane. Fine. This is the graph of the Z plane. And your target is to find the image in the W plane by using the mapping T of Z. First of all, as I mentioned you, the shape of the graph does not change. That means if this number is my triangle, fine, this region is also my triangle. And what is the value of the K? K is my greater than 1. So that means it will stretch the region. Therefore, if my region is here, then the answer could be like here. It will be stretching 3 times. So that I am trying to expect the output of this region. How you can prove that? It's a very simple. I can start from the transformations by taking Z is equal to X plus iota Y, W is equal to U plus iota V. I can substitute the value U plus iota V, which is equal to 3 into Z. Z is my X plus iota Y. Can you find the value of the U and V? You can equate the real and imaginary components. Okay, I can write here is you can equate real and imaginary parts. So U value will be my 3x, imaginary value will be 3y. y. Fine. Now, what is my given reason? X is equal to 0, y is equal to 0, x plus y is equal to 1. Now, can you find the value of the u and v? Whenever x is equal to 0, that means u is equal to 0. Whenever y is equal to 0, that means v is equal to 0. And whenever x plus y is equal to 1, if you add them, u plus v is 3 times x plus y. Therefore, u plus v is equal to 3. Fine. Now, can you draw the graph? Can you draw the graph of u is equal to 1, v is equal to in the uv plane? This is u. Fine. This is v. So, v is equal to 0, u is equal to 0, and u plus v is equal to 3. Fine. So, that means this is again shape is preserved, but it is magnified by the 3 unit is the right answer. And your target is to determine the reason, and the reason are my u is equal to 0, v is equal to 0, u plus v is equal to 3. Second one is find the equation of the image of the circle. This is the equation of the circle. Fine. Center is 0, radius is 1 in the z plane. Fine. And your target is to convert into the w plane. Fine. This is your target. Now again you can see the mapping is half of the z. The k will be my half, which is less than 1. That means the region will be shrink. If this is the original circle, in the after that it will be shrinking by half. But how you can prove that? Again, a very simple. I can take z is x plus iota y and w is u plus iota v. But you can see, क्या यहाँ पे x की वैल्यू दे रखी है? नहीं दे रखी. Fine. So my target is I can simply find the value of the z from these equations. We know that transformation is, can you find the value of the z? The value of the z will be my 2 of w. I can substitute the value of the 2w in the given equation of the circle. Fine. And once you can substitute in the given equation, you will get w is equal to half. What does it implies? This is the equation of the circle. Fine. What is the center? Center is 0. And what is the radius? Radius is my half. Why? Because whenever you have z minus a is equal to r, then this r is my radius and a is my center. Make sure, student, it must be negative. Fine. And how you can write this number is, I can write w minus 0 is equal to half. So can you draw them? Center is 0, radius is half. So as I predicted you, because k is my less than 1, it means it is shrinking the nature of the circle. And again you can see it is the equation of the circle. So that shape of the z plane is circle and the shape of the w plane is also circle. Okay, look at this next one. Let the rectangular region in the xy plane. So can you draw the graph? Fine. This is my xy plane. X is equal to 0. Y is equal to 0. X is equal to 2. Y is equal to 3. So that means this is my region. Fine. Now clearly say this region is my rectangle. Fine. Now if you are using this transformation, again the answer will be my rectangle. Fine. How you can predict that? Again a very simple. I can choose w is my u plus iota v. Z is equal to x plus iota y. I can substitute the value in the given equation number 1. Fine. So what is the value is? W is equal to root 2 e raised to power iota pi over 4 into z. Now let's start with the value. U plus iota v, which is root 2. What is e raised to power iota pi by 4? Cos pi by 4 plus iota sine pi by 4, and z is x plus iota y, which implies u plus iota v, which is equal to root 2. What is the value of the cos? So it is 1 over root 2 into x plus iota y. So clearly say root 2 and root 2 will be cancelled. U plus iota v is 1 plus iota x plus iota y. So can you equate the real and imaginary parts? Fine. So what is the real component is? If you multiply them, it's a x, and if you multiply by iota and iota y, it is minus 1. Similarly for the v, that is the imaginary component, that number will be my x plus y. Clear? Now what is given to you? The reasons are x is equal to 0, x is equal to y is equal to 0, x is equal to 2, y is equal to 3. Now what will happen if x is equal to 0? U is equal to minus y and v is equal to y. So what you obtained from these two equations, that means u is equal to minus v. Is it okay? Now look at the second case. When y is equal to 0, u is my x, v is equal to x. So this implies u is equal to v. Is it okay? Look at the third case. When x is equal to 2, that means u is equal to 2 minus y and v is equal to 2 plus y. So can you conclude them? If you add them, y and y will be cancelled out. U plus v is equal to 4. And similarly for the last case, when y is equal to 3, it will be x minus 3 and v is equal to 3 plus y. So clearly say if you subtract them, fine, if I use v minus u, then it will be my 6. Fine. Now you have these 4 equations. Can you draw the graph in the u? Can you draw the graph on the uv plane? Fine. So let's see. V is equal to minus u. This is the graph of the v is equal to minus u. V is equal to u. This is the graph of v is equal to u. This is the graph of u is equal to minus v. U plus v is equal to 4. This is the graph of u plus v is equal to 4. Fine. This is the graph of, and v minus is my. Clear? So if you draw the graph, you can see the common portion is highlighted with the red yellow color, and clearly say this number is my rectangle, this portion is also rectangle. So this is the way you can solve it in a very simple manner. These questions are exercise for you. You can solve them and let me know your answers in the comment box. I will upload the next lecture very soon on the inversion property, where the shape of the graph will change by using the transform. I hope you are really like and comment on this video. You can share this video with your friends. Happy learning always. Best wishes to everyone.